Okay, so nice and straightforward. I couldn't actually see answers below to this one because I just did this and I went to check it, and I don't think there are any answers, but it is very, very straightforward. So, like I said, when we're doing the spheres, it's 4/3 pi r cubed. Just don't forget the radius is from the center to the edge. So for here, you need to divide that by 2 to get your radius, that'd be 6. For question A, nice and simple, 4/3 pi r cubed, r's 2, so we're going to get 33.5 centimeters cubed. For this one, it would be the exact same working, except the radius would be 5. Okay, I'll just rub that out. The radius would be 5. Okay, everything else exactly the same. Okay, if we were doing it for the last one, the radius would be 6. Okay, nice and straightforward. So yeah, very, very easy. And you're given this equation in your sheet, so don't stress about it. So that's question 3A I've done there. For these hemispheres, it's again very straightforward. All you need to do is divide your final answer by 2. Okay, so you just take this and divide by 2. So for question D here, we would just say, okay, 4/3 times pi times r cubed divided by 2. Okay, so 4/3 times pi times r cubed, which is 3 cubed, divided by 2. Okay, so 3 cubed, 3 times 3 is 9, times 3 is 27. So we're doing 4 divided by 3 times pi times 27 divided by 2. You don't need to do that line if you're using a calculator, but that's what you're doing. Okay, so let's just work it out. So the full sphere would be 4/3, let's see, times pi times 27. So the full thing is 113. And then we need to divide that by 2 because we're doing a hemisphere. And that's going to give me 56.5, I call it 5, okay, centimeters cubed. Okay, it was 0.548, but I'll just call it 0.55. Okay, and actually I'm being a bit naughty. What I should really have said is, you should really just write your full answer to begin with and then round it later on. Okay, so just write the full thing and then do the rounding as the last mark. Because if you kind of round wrong and do your sums wrong, you could doubly hit the marks. Okay, so this is all very, very straightforward. You've got an equation that you're given. All you need to do is really identify what the radius is, and when you get funny shapes, don't forget your divide by 2, and that's why keeping your working nice and consistent. My handwriting's a bit rubbish, but keeping it nice and consistent, nice and neat, really helps. Okay, so that's what to do for these ones. Okay, straightforward. The next bit here, which we're going to go on to, which is kind of getting more to the National 5 type work, is really just saying identify your shapes and break them down. Okay, so look for, this is what's called a compound shape. Okay, so look for the two shapes. Okay, call them shape 1 and shape 2, work out the areas and then add them together. Okay, so in this case, we can see we've got a cylinder as the base and then we've got a cone at the top. Okay, and just work out the two shapes completely independently and then add them together at the end. Absolutely straightforward. Okay, they look complicated, but they're really not. Okay, we've just shown up here anything with a sphere in it, dead straightforward. We've just got one equation. Okay, there's anything up here that you would look at and say is particularly difficult. But when we start putting those shapes together, people can get confused. It's just trying to identify what shape we're looking at. Okay, and again, if you find it hard, you write down what you know. Okay, make a wee list and say, well, I know the volume of a cylinder, I know the volume of a sphere, etc. And then say, well, how does that help me? Okay, so that's a wee intro to the next video. Will we go? Yeah, okay, we'll just start this one just now. Okay, so I'll talk through question 1A. Okay, so what have we got here? Well, I would say we've got a base, which is your kind of cuboid, yeah. And then I would say on top of that, you've got your pyramid right here, that kind of shape. Okay, it's that kind of thing. So how do we work out the area of this? Well, for the volume, well, we take this area, yeah, and we'll times it by the length. Okay. How do we work out the area of this? Well, we're going to do the base times the height times a third, aren't we? Yeah. So we'll call that the volume of the cuboid. So that's going to be we just call that the breadth and the height. Okay, so it's going to be height times breadth times length, and this one's the volume of the pyramid. Okay, and that's going to be a third times, we'll call that the length and the width, and then the height. Okay, so it's going to be up here. Nice and straightforward. So on this one, what have we got? We've got 16.9 and 8 for our length and our breadth, but our height was 5. Yeah, so it's going to be 5 times 8 times 16.9. Okay, so that's our area we were talking about just there. Yeah, that's the 5 and the 8. 5 was the height, 8 was the width. Yeah, and over here, the base is going to be your 16.9 and your 8. Okay, so it's going to be your 16.9 and your 8. Okay, and the height for that one was 11. Okay, now sometimes what they do here for the heights, they might give you the height of the whole thing and then the height of one of the shapes, and you've got to work out, the extra height. Okay, but in this case, they have actually just given you the 11. What they might have said was the whole thing is 16 and this is 5, so you need to work out that's 11. We've not done that. So that's your two compound shapes for that. Very straightforward. Okay, over here we've got a similar thing. We've got another cuboid, and then we've got our triangular prism on top. So how do we get the area of this shape? I'll just actually zoom in. That's not helping. That's a similar kind of thing, isn't it? So let's work out the area of this shape here. So is that going to be a 5 times 5? Yeah. So that'll be your 25, and then let's times it by the length going in. So that's 10. Yeah. So 25 times 10, we know that that shape is going to give us 250. And this prism on top, well, what is the area of this triangle? Well, that's going to be 10 times 4 divided by 2, a half base times height. Yes, that's 40 divided by 2, which is 20. Okay, so we know that that's 20. And then we're going to times it. I'll just say meters cubed so I don't get confused. Meter squared. And then the 20, we're going to times it by the 5, aren't we? So 20 times 5 is going to give us 100. Okay. So that's 100 meters cubed. Add them together, 350 meters cubed. I'll just check that's right. Sure it is. Yeah. Okay. So we've got all the answers down here as well, nice and straightforward. But yeah, just nice and easy. We've got our cuboid and our triangular prism, cuboid and our cone. Okay. Time for, yeah, we'll do these two as well. This one, we've got our cylinder in the middle. I like it, put it in feet. Old money, brilliant. It's got exactly the same units. Well, the same process, but just different units. So don't stress the fact it's in feet. So what was our volume of this cylinder again? How do we do a cylinder? Well, the area of the circle was going to be pi r squared, wasn't it? Pi r squared, and then times it by the length. Okay. So in fact, I'm just going to write that over here because that's really messy. So it's pi r squared times the length. So that's a wee bit tricky. How do we know what the radius of this circle is now? We've got these spheres on the end. Now a sphere, this is kind of like circles in all directions, isn't it? Like everything's a circle and a sphere. It's just circle, circle, circle. So actually what this is saying is that if you were to look at that on its side, okay, there's your radius there, that's your 3, okay. But also, there's a radius there, that's also 3. Okay, so what this is trying to make you do is identify the relationship between the circle on the cylinder and the sphere. Okay, so the radius of your cylinder is going to be 3. Okay, so that's going to be pi 3 squared times the h, which was 10. So that's going to be what, 9 times 10, so it's like 90 pi, whatever that is. Going to be roughly 270. Okay, so that's your cylinder. And then you need to do the sphere. Again, you've got two hemispheres, so we'll just say that's one sphere. So what's the equation for a sphere? 4/3 pi r cubed. And what's the radius? Just 3 again. Okay, so 4/3 times pi times 3 cubed, don't forget. Okay, nice and straightforward. So that's a wee bit tricky because you've got to understand the relationship, but that's about as hard as it's really going to get. Okay, so there they've made you make that leap. Again, see if you don't know, have a guess. Absolutely guess. If you're looking going, well, wait a minute, I don't know what the radius for that is. Well, you notice there's a 3 there. So you're going to times by 2 or divide by 2 or it's that number. It's something like that, So have a guess. Just say radius is, And if you get it wrong, you get it wrong. You still pick up marks for following it through correctly, for having the correct strategy, for knowing it's a cylinder plus 2 hemispheres. There's marks for that, okay? Again, with these, actually, I probably should have said, you really want to write down a strategy and say, you know, volume of shape equals volume of cylinder plus 2 hemispheres. So therefore, volume of shape is volume of cylinder plus 1 sphere. That's worth a mark, I think, you know? So make sure you do something like that. Very finally, cylinder in a cylinder. So we've got a big cylinder, it's a toilet roll, isn't it? We've got the inside is cut out of the big one, okay? So how do we do that? Well, we just do one shape, take away another, don't we? So what's the area, the volume, sorry, of the big cylinder? Well, the volume of the big cylinder is going to be pi r squared h, yeah? And we're going to take away the small one, which again is going to be pi r squared h. So what's the radius of the big one? It looks like half of that, so it's going to be pi 7 squared times the height of 27. And then we're going to take away pi times the smaller radius, which is going to be 2 squared times the height of 27. Okay, fine. You could actually have done the areas on the top, that area, take away that area, then times by the height. So you could have done, you know, pi r squared, make it minus pi r squared, then times it all by h. You could have done that. But this is just textbook, doing a whole cylinder, take away another cylinder. Okay, nice and straightforward. So having a strategy is a good one. You know, big cylinder, again, there you should have written big cylinder, take away small cylinder. Okay, and knowing your radius is half of the 4 and half of the 14. But nothing difficult there at all. And again, don't forget your units. Nice one.